and welcome back to Global Climate Change. This is Lecture 7. Uh, Hope you guys had a good week last week, a good weekend. Just want to point out to you there is some reading that I'd like you guys to do. Just a couple pages, not too many, for this week. This lecture is actually going to be about the carbon cycle, as you guys can see inside of your, inside of your modules. So, we're going to learn about the carbon cycle today, and we're going to kind of talk about, the long term and the short term carbon cycle, and then what's involved in both of those things. So, I do have a couple goals for you guys for this specific lecture. I want you to be thinking about these things as you watch it. Understand the difference between the short term and the long term carbon cycle, and also understand the main components of the long term carbon cycle. So first of all, this is going to be basically, I think you guys have seen this, this is going to be the CO2 over at the mountain over in Hawaii. This is going to be the CO2 concentrations in parts per million, the year from like 1958, here to, about the year 2000. You can see that there's definitely some variations here going on because it's got a wiggle, and this wiggle, the cycle is pretty consistent. I mean, you can see the trend is going up. Obviously the amount of CO2 is going up, but the actual, the cycle of up and down, is pretty consistent and pretty much the same. So we're going to go over kind of what that's about and the things that are contributing to the carbon, that would be short term within the shorter term. So, first before we kind of go through the carbon, we need to kind of go through the 5 spheres of, Earth, basically. This is going to be the atmosphere, the hydrosphere, the cryosphere, the biosphere, and then the geosphere, which is solid Earth. So these 5 spheres are actually going to be the thing that makes up our planet, and they run the Earth, basically. Now, when we're looking at the planet and we're looking at the carbon cycle, we're looking at many different things, and you want to take a holistic view of the planet, then we're going to need to keep all 5 of these spheres actually in mind when we're talking about it. So these are going to be basically like kind of our 5 spheres here. We have the hydrosphere, the cryosphere, the geosphere here, the atmosphere, and you can see how there's definitely a lot of interaction between them. There's going to be changes in solar inputs, heat exchanges between the water and the atmosphere, wind stress. We're going to have changes in the circulation, the sea level. We're also in the hydrosphere going to have rivers and lakes. We'll have human influences, things like power plants. We'll also have glaciers and volcanic activity and clouds. Here in the biosphere, then we'll have the plants here, along with the soil biosphere. So there's all these different parts of our planet, and they're all working together, and to basically move different things, and especially carbon, actually through our planet. So the cryosphere, what exactly is it? Okay, we're going to have glaciers, which are extended masses of ice which are formed from snow falling and accumulating. So these things are like around for a very long period of time and get very compact because the snow just keeps falling on it and it accumulates. These move very slowly, and they move down mountains and away from centers of accumulation. So they do have a little bit of motion to them, but it's very, very slow. And then we're going to have ice sheets, which is going to be, Antarctica, Greenland and Patagonia. We'll have the sea ice and the snow fields, where the sea ice is going to be frozen seawater within the Arctic Ocean. These do go as far south as China. We do have a couple different kinds of sea ice. We have pack ice, land fast ice, marine ice, and then those snow fields. Now, when we're talking about the cryosphere specifically with the climate, we talk about how it'll affect the albedo, how it affects the feedback systems. We just went through feedbacks last week. There's going to be a positive feedback associated with the cryosphere. And then it's going to store large amounts of water. And, the sea level will vary based upon how much water it's actually going to store within it. So, we can see here that we do have glacier retreat going on. This is going to be 1913 versus 2005. I mean, visually, you can definitely tell a huge difference between, the amount of glaciers that we had in Glacier National Park in Montana in 1913 versus how much we have right now in 2000. Well, it's not 2005 anymore, but when we had then. This is going to be Alaska, McCarty Glacier. Look at the difference here. There's this huge difference between how much we're going to have contributing to the cryosphere between 1909 and 2004. Now, what exactly is carbon? First most abundant element in the universe. Fourth most, abundant element in the universe. So it's pretty abundant. There's quite a bit of carbon going on at all different times. And it is a building block of life. Okay, it goes from fossil fuels and DNA down to carbon cycles to the land, ocean, atmosphere, and the solid earth. And carbon can be found in all living things. Also in the atmosphere, in the layers of limestone sediment in the ocean floor, and in fossil fuels like coal. So fossil fuels, coal that's in our land or down in the earth is going to hold lots of carbon in it. Now, where is it? In the atmosphere. Now remember, carbon can exist in more than one form. It's not just CO2, but we also have CH4, and then we also have CO. Now just to kind of give you an idea, CO2 we're at around 400 parts per million, CH4 we're at 1.51, and CO we're at 0.13. So most of the carbon is actually in CO2, but we also find it in other areas as well. We also have, plants and animals, also in sugar, soils and in methane. We also find the carbon in the oceans and as dissolved CO2, and most carbon is in the deep ocean that's in the ocean itself. And carbon, is going to be a conserved thing. The initial carbon present during the Earth's formation it is the same as it is right now. The carbon doesn't actually increase or decrease globally. It's just where it is and what form it's actually in. So carbon is exchanged between different components of the Earth system, like I said, where it is. And the complex series of reactions by which carbon passes through the Earth. So, is it in the form of CO2 or is it down in the ocean? Is carbonate? Where is the carbon actually located? In the atmosphere, in the land or solid earth, in the, which would be the crust, and the oceans. These would be, very much interactions between these three different spheres of our Earth. And the carbon is also exchanged throughout the Earth system at all time scales. So remember in the beginning I said I wanted you guys to kind of keep in mind, our goals would be understanding the short-term and the long-term time cycles. So the long-term cycle is going to be hundreds to millions of years, where the short-term cycle will actually be seconds to a few years. So there's going to be one cycle that's kind of going on. It's going to take a very long time, and then another cycle is going on that's going to take a lot less time. And here's a nice little depiction of, the amount of carbon that can actually be exchanged, through the spheres, how long it can take and how much of it there might be. We'll go into this here more in a moment. So again, to go back to the short-term carbon cycle and the long-term carbon cycle, we're going to start with the short-term carbon cycle. So one example of the short-term carbon cycle involves plants. Now, photosynthesis, converts carbon dioxide and water into sugar, right? Called carbohydrates, using sunlight. Oxygen is produced as a waste product. So it takes in carbon dioxide or carbon and then puts out oxygen. Plants use this carbohydrate as a form of nourishment to grow, this sugar basically. Now, that's when it actually grows and when it's thriving and the plant's doing great. But after it dies, there's going to be decay and carbon is actually going to be returned into the atmosphere during that time frame. So, if we're thinking about a short-term carbon cycle, we can say during the spring and the summer, there's going to be more photosynthesis, okay? And during the fall and the winter, there's going to be more respiration. Well, what does that really mean? During the spring and the summer is actually when we're going to have less CO2 in the atmosphere because the plants are actually going to be taking it in order to do what it needs with photosynthesis. And then during, the winter or the fall and winter, it's going to have, more respiration, meaning there's going to be more decay, and the decay is going to release more carbon into the atmosphere. So during the spring and the summer, CO2 levels go down, and then during the fall and the winter, they go up. Now that would be the reason for these little wiggles right here. In 1 year, we're going to have the spring and the summer, and then we're going to have the fall and the winter, the spring and the summer. Sorry, the way around. The fall and the winter, and the spring and the summer, the fall and the winter. And it'll just, keep going up and down. And here's a nice little zoomed in portion of it here for you. You can really see how like every year is basically what that cycle is going to be. So when are CO2 levels highest? Which month? They're actually going to be highest in the month of May because that's the end of the winter. Okay? May is going to be the beginning of when plants are going to start growing and the decay is going to end. So that's the highest point, right? It's going to be happening throughout the winter, throughout the fall, but it's going to keep happening and it'll be highest right at the end, right before the plants start growing. My daddy, actually, he gardens, and he's always telling me Mother's Day is the time to plant because that's when the plants are growing. So May is going to be that time where they're going to start in most areas of the world. And they're going to be lowest in September, October because it's the end of the summer, right? So that's when things are starting to die. So it's going to be the end of their living time when photosynthesis will be at its greatest. And here's kind of an idea right here of, we have the exchange between, the plants, the sun's coming down, the photosynthesis is going to happen, right? The plants are going to take the carbon in, but then once they start decaying, then it's going to release the carbon into the atmosphere. We're going to have this process, happening seasonally. And then we're going to get into long-term carbon cycles. Remember, these long-term is hundreds of years to millennials. So carbon is slowly and continuously being transported between the Earth's systems. The atmosphere, the hydrosphere, the biosphere, geosphere, rocks like limestone are going to be, the Earth's crust. So the main components of the long-term carbon cycle are chemical weathering, subduction and volcanism, organic carbon burial, oxidation of organic carbon. Sorry, those 4 things. We will go over actually each one of these here right now. So the long-term carbon cycle diagram is going to kind of look like this, right? First, these carbonates are going to, It's distracting me. I'm sorry the way I was doing that. Is going to be released out of the ocean, through the silicate to carbonate conversion. It's or through subduction and volcanism, and it's going to basically go up and then into our atmosphere, or our ocean, the biosphere. It's going to basically come out of the deep, deep areas of the ocean, and start being dissolved or like brought up into where we live here. Okay, and at the same time, the buried organic carbon, the buried stuff, down deep into the sediment is actually going to, through erosion or oxidation, it's going to be brought up as well. And then the atmosphere and the ocean and the biosphere are going to have more carbon in it, but then through the silicon to carbonate conversion, we're going to bring it back down into the carbonate form, and also through organic carbon burial, then it's going to go back down into the buried organic carbon. So we're going to kind of go over this a little bit more right now. So if you don't completely understand it, don't worry. All right, so the silicate to carbonate conversion is one component of it. And, first of all, what is silicate, right? It's a rock, okay? Something like granite, okay? Or we have a carbonate, which is going to be limestone. Okay, so this silicate and the carbonate, these components of it are actually going to be rocks or things that we might find in the geosphere. So the silicate to carbonate conversion, between those two rocks, silicate to carbonate conversion, are going to have 3 different phases to it. First, it's going to have the chemical weathering phase. Now, that's when basically CO2 and rainwater combine to create carbonic acid. Okay, this carbonic acid is going to dissolve the silicate rock. Okay, it's actually going to act like an acid and actually dissolve it. Okay, so instead of weathering, bringing the thing that breaks it down, like wind or water or something like that, the acid is going to be the thing that wears it down. And then after it gets, worn down, by the rainwater with the CO2, then it's going to be transported. Okay, it's going to be transported to oceans by rivers because remember it's in rainwater, right? So it'll come through the rainwater down into the rivers and then down into the oceans. And the last phase is going to be the formation phase, and that's where in oceans, calcium carbonate precipitates out of the solution and settles to the bottom. Basically what happens is, the carbon is going to separate and it's going to go down to the bottom of the ocean and it'll be down there for quite a while. Remember, this is the long-term carbon, one of the, piece of the long-term one. So we're talking many, many hundreds of years to millennials, it's going to take for this to happen and for it to be down at the bottom of the ocean. So here's kind of a nice little, I don't know, crude drawing that we tried to do here. So we got, the CO2 dissolves in the rainwater, right? That's step number 1. And then step number 2, the acid will dissolve, right? And then it's going to go down from the rivers into the ocean. This is going to be the ocean right here. And the dissolved materials will be transported to the oceans. And then, you can see how that carbon is going to separate out and then go down into the bottom of the ocean as calcium carbonate. So the changes in chemical weathering, this process is temperature dependent. So the rate of evaporation of water is temperature dependent. I mean, obviously, right? More if you warm up the substance, then evaporation is more likely to happen. So increasing temperature increases weathering, right? More water vapor, more clouds, which is going to cause more rain. That rain will be able to combine with the CO2 and we're going to have more of, the chemical weathering able to happen. Now, as the CO2 concentrations increase, the plant is going to warm, right? Because it's a greenhouse gas. Now, evaporation, because it's warming, the evaporation will increase. Okay, so the flow of carbon into the rock cycle increases. And that removes CO2 from the atmosphere and lowers. And then because we're removing it from the atmosphere, then it's actually going to lower the planet's temperature. So hopefully you guys are thinking about feedbacks right now, right? Which type of feedback is that? That's going to be negative feedback, okay? Because it's going to, go in one direction and then kind of go back to where it was, to begin with. And then we have, another long-term carbon cycle here, which is subduction and volcanism. Basically subduction is going to be the process where the ocean plate is going to go beneath the continental plate. Here's the continental plate right here, continental crust. So that ocean plate is going to go down beneath it. During this process, extreme heat and pressure, we know when that happens, there's a lot of pressure that happens here. It's going to convert carbonate rocks into CO2 eventually. Now, that brings it down, right? But what brings it up is going to be the volcanic eruption. Okay, the eruption can inject a lot of things into the atmosphere. All right, these are in megatons right here. If you look at that, so 17 megatons of SO2, 42 megatons of CO2, 3 megatons of Cl can inject large amounts of CO2 in the atmosphere that way. In 1991 we had Mount Pinatubo. Which erupted, and that just, completely spiked the CO2 levels because it erupted so much of the CO2 into the atmosphere. All right, now, here we have 2 components of the long-term carbon cycle, and that's the organic carbon burial and the oxidation of buried carbon. So buried organic carbon is where living plants remove CO2 from the atmosphere by the process of photosynthesis. Now, when dead plants decay, the CO2 is put back in the atmosphere. We kind of already went over this. This is fairly quickly when the carbon in the plants is oxidized. So, we saw that as a seasonal variation. But that's a short-term, cycle. We're talking about long-term cycles right now. Okay, so some carbon escapes oxidation when it's covered up by sediments. So sediments will actually come, on this dying or dead, plant, and it's going to cover it up. And when it covers it up, here's another little crude drawing here to show you kind of what's going on. Hopefully you love that dead plant over there. So, we're going to have basically our plant, and the carbon will be in the plant, right? And then the plant is going to die. Okay, some of it's going to leave the plant in the form of CO2, right, during respiration. But some of the O2 will actually go out of it, leaving the carbon in the plant because the sediment will actually be, coming over it. And then, it'll go down into the soil as carbon, okay? And then the carbon will actually be stored in the land. And so that means that some of this carbon is actually escaping the oxidation, which is the short-term one, and then enters the long-term cycle, which is the carbon burial process. Okay, so eventually buried organic carbon may be exposed by erosion. Okay, so this is a cycle, right? So it goes down into the ground and is there, but erosion will happen, and eventually some of it actually might be exposed. Now the carbon is then oxidized, I can barely say that word, into CO2. So here's kind of a nice little depiction, or crude depiction, if you will, of that as well. We have our atmosphere, and then, this is going to be like basically the carbon and the buried carbon. And then we're going to have, the land kind of come down through erosion, and it's going to kind of like come down into where this buried carbon is, okay? And then it's going to release the carbon into the atmosphere, okay? And, it's going to mix with that O2 and form CO2. So, the almost complete long-term carbon cycle, right? We have a few different components to it. We have an inorganic component, which is going to be the silicon to carbonate conversion, and also the subduction of volcanism. And then we're going to have the organic component to it, which is going to be the organic carbon burial, and then the oxidation of buried organic carbon. And this is the end of our lecture for this week. So I hope you guys have a terrific week, and thanks for watching.